Hi everyone, welcome back to the channel. I'm Salman, and in today's video, we're diving into the mathematics section of the YÖS ALFA third trial exam. As usual, if you haven't taken the exam yet, make sure to download the PDF file from the description down below and try solving the problems on your own first to get the most out of this video. So let's get started. B and C are digits. What is the result of this operation? So let's simplify this by multiplying each digit by their respective values. For example, AAB can be written as 100 times A plus 10 times A plus B. In the same way, BBC can be written as 100B plus 10B plus C, and CCA can be written as 100C plus 10C plus A. So the first one is 100A and 10A, 110A, and there is one more A. So 111A plus we have in the same way 111B plus 110, 111C. On the numerator, we have 111A plus B plus C. So these two cancel out each other, and we have the result as 1, which is A. Number 2, PR, S, and M are integers, and this relation is given. What could be the result of the sum P minus S plus R plus M? So let's write it down. P minus S plus R plus M, and we're given the summation of B plus R as S plus M. So we have S plus M, and there is minus S, and there is plus M. And the summation gives us 2M. Since 2M is an even number, let's take a look at the given answer choices. And the only even number in the choices given is minus 18. So our answer is D. Number 3. A, B, C, and D are consecutive odd numbers. What is the result of the operation? So we can write these four consecutive odd numbers as 2n plus 1 for the first odd number, since this is the general format of an odd number, considering that n is an integer. So the next odd number would be 2n plus 3, and the next is 2n plus 5, and the next is 2n plus 7. So these are A, B, C, and D. We can cancel out 2 n's from each term. So we have this relation between A, B, C, and D. So we want to find out D minus A over C minus B. D minus A is 7 minus 1, and C minus B is 5 minus 3. From here we have 6 over 2, which is 3. So the answer is E. In the operation shown on this side, each dot represents a digit. What is the digit A? A is asked. So the first step is the multiplication. So to have 5, this dot can be 1, 5, 3, or 7. We'll check one by one. If this dot is 1, 1 times 5 is 5, 1 times 2 is 2, this is 7, so 1 is impossible. Let's continue with 5. 5 times 5 is 25, 5 is over here, 5 times 2 is 10, and then there's 2 over there. So it's going to be 12. So this is 2 if it is 5. So 5 is also eliminated. If it is 3, then we have 3 times 5 is 15, 3 times 2 is 6, and there's 1, so 7. 3 times this is 3 is 9. So everything checks out if it is 3. So we use 3 here. So in the second step, 325 times 2 is 650. So the summation of these two is 5, 7, 14 here, 7 here. So the answer is C. Number 5. E and N are given. Which of the following is the value of N in terms of A? We're asked to find N. Okay, let's sum them up. N plus A is equal to 36 plus 38 is 74, which is twice 37, plus we have 27 plus 1 is 28. On the denominator we also have 28, so we have 1 over here. From here we have N is equal to 3 minus A, so the answer is C. Number 6. This equation is given. We're asked to find X. So let's simplify this. 1 plus 1 over 2 is 3 over 2 times 4 over 3 times 5 over 4, and as the last term we have 5x plus 1 over 5x. The product of all these is equal to 63, and on simplification we have 5x plus 1 over 2 here is equal to 63. From here we have x is equal to 63 times 2 is 126 minus 1 over 5. So the answer is 25. It's D. Number 7 is a simple addition and subtraction problem. Let's simplify this. 4 minus 3 over 2 is 5 over 2 plus 3 over 2. On the denominator we have 7 minus 12 minus 5 over 3 minus 7 over 3. From here we have 8 over 2 and minus 12 over 3. This is minus 4. This is 4. So the answer is minus 1. It's A. Number 8. A is the digit, and what is the result of this operation? So let's simplify the operation first. Since we have 3 terms equal, the summation is 3 times A point A bar over, since these two are the same, 2 times A point 0 A bar. So let's simplify this. A point A bar is equal to AA minus A over 9. AA minus A is the same as 10A over 9. For the second expression, A point 0 A bar is equal to A0A minus A0 over 90. From here we have 100A plus A is 101 minus 10A over 90, which is 91A over 90. So let's substitute these values into this expression here. So we'll have 3 over 2. The first one is 10A over 9, and the denominator is 91A over 90. So it's 90 over 91A. Okay. Now we can simplify this expression. This A and that A cancel out each other. 9 times 10 is 90. 2 times 5 is 10. So the result is 150 over 91. It's D. Number 9. This expression is given and one more equation is given. Which of the following is true? So let's simplify this. T is equal to 2 plus B over A. We can find B over A from here. Since both A and B are negative, let's try and give it a value so we can see it more clearly. So from here, B over A is 0 point something. It's between 0 and 1. So 2 plus some value between 0 and 1 gives us 2 point something. So the answer should be larger than 2 and less than 3. It's D. 10. Y is an integer. Sigma y is asked, the summation of all the possible y values. So how do we find y? Let's start from here. We're going to cross multiply these two to have 6x plus 2 is equal to 5 minus y. From here we have y is equal to 3 minus 6x. So we need to know x to be able to solve for y. How do we find x? We can find x from here. Let me draw a number line so we can find out the x value. Let's say this is positive infinity, this is negative infinity, and we're going to have checkpoints in between 0, 1, and minus 1. Let's check this region and see if it is correct. So let me pick any value between 1 and infinity. Let's say 2. If x is 2, then let's write down this relation and see if it is correct. 2 cubed is 8, and 2 squared is 4. Since 4 is not larger than 8, this region is not correct. Let me check this region. Between 0 and 1, let me pick a value. Let's say it's half. If x is half, let me write down this relation. X is half, and x cubed is 1 over 8. X squared is 1 over 4. Since 1 over 8 is not larger than 1 over 2, This is also incorrect. So we will continue checking this region between -1 and 0. Let me pick any value. Let's say negative half. And let me write down this relation and see if it is correct. Negative half, negative 1/8, and 1/4. Since negative 1/8 is larger than negative half and less than 1/4, this region is correct. So x is between -1 and 0. Let me check this region too. Let me pick any value between -1 and -infinity. Let's say it's -2. And let me write down this relation again. -2 cubed is -8, and -2 squared is 4. Since -8 is not larger than -2, this is also incorrect. So we're not going to pick that region either. So the only possible x value is between this range, -1 and 0. So we have x now. How do we find y? So y is equal to 3 minus 6x. We'll first multiply x by -6. So we have 0 and 6 over here. -6x plus 3 is equal to y. So y is between 9 and 3. And y is an integer, so this is y. All the possible values of y are 4, 5, 6, 7, and 8. And if y is equal to 5, we're going to have 5 minus 5, 0 on the denominator. So this equality is going to be undefined at that point. So we will eliminate this point. What is left is 4, 6, 7, and 8. So sigma y is the summation of all these. 10 and then 15. The summation makes 25. So the answer is A. Number 11. What is the sum of the x values that satisfied the equation? So let's solve for this. X cubed minus 1 is equal to x minus 1, x squared plus 1 plus x. And we can write the absolute value this way. So this thing and that thing over here cancel out each other, and we're left with x minus 1. The absolute value is equal to 7. From here we have two solutions. X minus 1 is equal to 7, or x is equal to 8 from here, and the second solution is x minus 1 is equal to -7, x is equal to -6. So let's check if these values make the denominator 0 or not. If it is 0, if the denominator turns out to be 0, then we need to eliminate that solution. So x is equal to 8 is okay, since this function is already positive. Okay, when x is equal to -6, we have 36 minus 5 is 30. So this is not 0. So we can choose both answers. So there are two solutions for this equation. So the answer is B. 12. This inequality is given. We're asked to find the summation of the smallest x value and the smallest positive integer value. So let's solve this inequality first. We need to find the critical points, and they are found when we equate these two expressions by 0. So we have x is equal to 3 and x is equal to -5. And we should check the interval accordingly. We have -5 and 3. This is positive infinity, negative infinity over here. So we are going to have three regions. The first region is here, between -infinity and -5. So this is our first region. The second region is over here, and the third region is over here. Let's first start with the first region. When x is less than -5, what do we have? If x is less than -5, this part is going to be negative, so we should multiply the whole expression by negative when this expression is out of the absolute value. So this is also negative, so we have the inequality as -x plus 3 minus 5 less than or equal -x minus 5 plus x. From here we have -x and plus x cancel out each other, so x is here, -2 plus 5, so it's 3. X is larger than 3, but our domain is defined as x is less than -5, sorry. So on this region, this is our x-axis, and our solution set is x is larger than 3. It is here. So it is out of the domain region, so we don't have any solution here. In order to have solution, the solution set should be in the domain region. So let's check the second case. It is where x is between -5 and 3. So when x is between this range, what do we have here in this inequality? Larger than minus 5, less than 3. If x is less than 3, then this is negative. So we have 3 minus x minus 5 less than or equal. If x is between minus 5 and 3, this is positive. We can also have equality over here. So we can write x plus 5 plus x. Solving this inequality, we have 3x and here minus 2 and minus 5, so minus 7. So x is larger than or equal to minus 7 over 3. Let's check the domain. The domain is defined to be between minus 5 and 3. And our solution set is larger than minus 7 over 3. So minus 7 over 3 is somewhere in the middle, and this is our solution set. So we will take the overlapping part as our solution set. So it is x is between minus 7 over 3 and 3. This is our first solution set. The second solution set will come from the third region. So the third region is where x is larger than 3. So if x is larger than 3, this is positive. We could also have equal sign here. So x minus 3 minus 5 less than or equal. When x is larger than 3, x plus 5 is positive. So we have this inequality. From here we have 2x and there is 1x. This x cancel out each other. So we have x is larger than or equal to negative 13. So let's check with the domain. X is larger than 3. This is our domain, and our solution set is x is larger than minus 13. So we will choose the overlapping part as our solution set. So x is between 3. Okay, x is larger than 3. X is equal to or larger than 3. So that is our solution. So our final solution is the union between these two. So this is between minus 7 over 3 and 3. So in this region. And this one is x is larger than 3, so in this region. Since we are looking for the union between these two, our solution set will be x is larger than or equal to minus 7 over 3. So this is our final solution. Let's go back and check what the question asks. The smallest x value is minus 7 over 3, and the smallest positive integer is plus 1 in this range. So we have minus 4 over 3 as our answer. So it's D. 13. Set A is given, B union C is given, A intersection B union A intersection C is asked. We can write this expression as A intersection. Since this A intersection is taken out, what's left is B union C in the parentheses. So B union C is given, 3, 4, 5, 6. A is given. The intersection between the two is 3 and 4. So the answer is E. 14. This equation is given. A is asked. So let's simplify this by taking out 2 to the A of the parentheses. So we have inside the parentheses 1 plus 3 to the A plus 5 to the A over 1 plus 3 to the A plus 5 to the A. So these two cancel out each other. On the right hand side of the equation, since 1 to 8 is 2 to the 7, we have 2 to the minus 7 on the right hand side. Since the bases are the same, we have A is equal to minus 7. The answer is A. 15. The equation is given and A is asked. So we have 5 to the 69 over here. We can also find 5 to the 69 from the first term by writing 5 to the 69 times 5. We already have 11 over here. So this term is again the same as 55 times 5 to the 69. So this is positive and that is negative. So the two cancel out each other. We have negative 5 to the 15 on the left hand side of the equation. On the right hand side of the equation, we can write 0.2 as 2 over 10, which is again 1 over 5. So from here we get minus 5 to the minus A is equal to minus 5 to the 15. Since we have the same basis here, we can equate their powers. So our answer is A is equal to negative 15. 16. How many times larger is root 3 than the number 2 minus root 3? Root 3 is larger. How many more times than 2 minus root 3? So we're asked to find this out. So let's rationalize the denominator by multiplying 2 plus root 3. So we have 4 minus 3 on the denominator, and on the numerator we have 2 root 3 plus 3. So the answer is 2 root 3 plus 3, C. 17. A is greater than 5. To what is the following expression equal? So we're asked to simplify this expression so that we have one of the answer choices given. So this can be simplified as this way. Root 5a is the same as root 5 times root a. So the whole expression inside the square root becomes root a minus root 5 the whole square. Be careful, we need to write down root a first because root a is larger than root 5. Otherwise, if you reverse the order, when the roots cancel out with the square power, we're going to have the negative value, which is incorrect. I mean, minus 3 the whole square is not equal to minus 3. It's supposed to be positive value. So to take care of this, I write the larger one first here. So from here we have root a minus root 5, and we also have this written here. So when we rationalize this, we have plus root 5. The two root 5s cancel out each other, and we got root a as the result. So the answer is A. 18. Which of the following is the simplified form of the expression above? When we take out negative 1 as the common factor from the numerator, we have negative x squared minus 100 over x squared plus 1 plus this. And this term on the numerator is exactly the same as what we have on the denominator. So these two cancel out each other, and our answer is minus 1. Which of the following is the simplified form of the expression above? So let's simplify this. When we check the numerator, we see that if we have 2 here, then we can make it a perfect square. So let's add these two. In order not to change the value, we should have negative a squared. And the first 3 terms is a perfect square. A squared plus 1 the whole square. And we have negative a squared. When we factor this out again, we have x squared minus y squared format. So we have a squared plus 1 plus a, and a squared plus 1 minus a. So a squared plus 1 plus a's cancel out each other. So we're left with a squared minus a plus 1, which is C. 20. The summation table and the multiplication table are given. So let's write down the equations. M plus L is equal to 9. From the second table, we have K times L is equal to 21, and K times M is equal to 42. When we divide these two equations, we have L over M is equal to 1 over 2. And from the first table, we know that the sum of M and L should be 9. So that means when we multiply both numerator and denominator by 3, we have 3 over 6. Now we have 3 plus 6 is equal to 9. That means M is equal to 6 here. And this is what we are asked. So the answer is D. 21. The graph of f of x is given. We're asked to find this. So let's write down the function. Y is equal to f of x. That means f inverse of y is equal to x. So f inverse of minus 2 means what is x when y is equal to minus 2? When y is equal to minus 2, our x value is 2. So this one is 2. And f of minus 2, when x is equal to minus 2, what is y? When x is equal to minus 2, the y is 3. So we have 2 plus 3 on the numerator. And this one is the same as f of 2. f of 2 is minus 2. And f of minus 2 is 3. So this result is 3. And this is the same as f of 2 plus f of 2. So f of 2 is minus 2. And f of 2 plus f of 2 is minus 4. So we have Minus 4 plus 3 is minus 1, and there is plus 5. So the answer is minus 5, B. Number 22. The inverse function is given, and this one is asked. So we'll first change the inverse function to the normal function. X is equal to f of x over 3. And how many times do we have f here? Let's count this. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 times the function f. Let's start with the first one, f of 3. To get f of 3, our x should be 3 squared. When x is 3 squared, our output is 3 squared. So from here we have f of 3 is equal to 3 squared. And for the second f over here, since f of 3 is 3 squared, we'll have f of 3 squared for the second f. To get f of 3 squared as the input, our x should be 3 cubed. So our output should also be 3 cubed. So f of 3 squared is equal to 3 cubed. And likewise, since this is 3 cubed, our next f is going to be f of 3 cubed, which is the same as 3 to the 4. So if we keep going like this, for the last f over here, we'll have f of, since we have 8f, we have 3 to the 8 as the input. So from here, look at the pattern. When the power of the input is 1, the power of the output is 2. When it is 2, it becomes 3. If it is 3, we have 4. So if it is 8, we're going to have 3 to the 9 as the output. So the answer is E. 23. The two operations are defined this way. In other words, we have two equations and two unknowns. That's the first unknown, and this is the second unknown. So we can sum up these two equations. So this and that cancel out each other, and we have a new equation. 2 times a circle b is equal to a squared plus b squared. From here, 5 circle 3 is asked. So 5 squared plus 3 squared, 25 plus 9 over 2 is our answer. So 34 over 2 is 17. The answer is B. 24. This table is given and this operation is asked. So we'll start with b squared. B and B intersection is E. So b squared is E. And to find c to the 5, we need to find c operation c. Operation c, there will be 5 times. C and C intersection is B, and B and C intersection is A, and this is A and C intersection is E, and E and C intersection is D. So C to the 5 is D. B squared is E and C to the 5 is D. E and D operation is E. So the answer is E. 25. One equation is given. We're asked to find P of x. So there are two ways to solve this problem. The first way is by taking P of x as second order equation. Since we are having the second order equation on the right hand side, that means P of x is going to be ax squared plus bx plus c. When you substitute P of x plus 2 and P of x minus 1 into this equation and then equate the terms with the right hand side, we can find a, b, and c, but it's going to take time. So let's use the shortcut. I can just assume x as any value. For the sake of simplicity, let me use x is equal to 1. So we have p of 3 plus p of 0 is equal to p of 1 plus 7 is 8. 8 times 2 is 16. I'll check which one of the following is 16 by using p of 3 and p of 0. So from choice A, p of 3 is 3 squared plus 3 times 3 plus 7 plus p of 0 is 7. The summation of all these terms gives us 32, which is not equal to 16, so that's not the answer. Let's continue with choice B. P of 3 is 9 minus 9 plus 7. P of 0 is 7. From here we have 14, which is not 16 again. So let's continue checking one by one. So P of 3 is 18 plus 1, and P of 0 is 1. We have 20 here. Again, not 16. So let's check choice E. P of 3 is 9 minus 3 plus 5, and P of 0 is 5. So 5, 5, 10, 19 minus 3 is 16. So we have this. Let's continue choice D. If it is 16, we need to check P of another number other than 1. Let's say x is equal to 0. Okay, let's check this first. P of 3 is 9 minus 4. P of 0 is minus 4. So this is 1. It's not equal to 16. So our only choice with 16 is E. So this is our answer. If any other choice turns out to be 16, then we'll have to try with different x values again. So you need to check all the choices and select the best possible answer. P of x is given. X is equal to minus 3 is a double root of the given polynomial. M plus n is asked. We can write this equation as x plus 3 is equal to 0. Since it is a double root, we can square this expression like this. And this is a factor of P of x. In other words, P of x is divisible by x plus 3 the whole square. So we can write P of minus 3 is equal to 0, which is again equal to minus 27 plus 27 minus 3m plus n. So our first equation is minus 3m plus n is equal to 0. To get the second equation, we can make use of the derivative of P of x. So 3x squared plus 6x plus m. And from here, if P of x is divisible by this, P prime x is also divisible by this. So P prime minus 3 is equal to 0 too. Minus 3 squared is 9. 9 times 3 is 27. Minus 3 times 6 is minus 18 plus m. From here we have m is equal to minus 9. Let's substitute this value into the first equation. So we have minus 3 times minus 9 plus n is equal to 0. From here, n turns out to be negative 27. Since we are asked to find m plus n, our answer is minus 9 plus minus 27, which is minus 36. So the answer is A. 7. What is the sum of the roots of the equation? Let's factorize this. X and x. Over here we have 5 and root 2. Since we have 5 minus root 2, this should be positive. That should be negative. So x plus 5, x minus root 2 is what we have on the numerator. On the denominator, we can factorize it this way. 6 and root 2, since we have negative 6 and negative root 2, we can factorize it this way. So x minus 6 times x minus root 2 is what we have on the denominator. So now x minus root 2's cancel out each other. We have x plus 5 over x minus 6 is equal to 0. Let's multiply both sides of the equation by x minus 6. So we have x is equal to minus 5 or x is equal to 6. X is equal to 6 is impossible because when we have x is equal to 6, we have 0 on the denominator, which is undefined. So the answer is D. Number 28. The solution set of the equation is C1. The solution set of another equation is C2. We're asked to find the elements of C1 union C2. So let's start from the first equation. By squaring both sides of the first equation, we have 3x minus 5 is equal to x minus 5 the whole square, which is then equal to x squared plus 25 minus 10x. Let's simplify this. X squared minus 13x plus 30 is equal to 0. From here we have x values as x is equal to 10 or x is equal to 3. Let's substitute these values back into the given equation and see if everything checks out. When x is equal to 10, we have 30 minus 5, which is 25, and the square root of which is again 5. And x is 10, 10 minus 5 is 5, so the first one is okay. X is equal to 10 is fine. When x is equal to 3, we have 9 minus 5, which is 4. Square root of 4 is 2, and On the right hand side of the equation, we have 3 minus 5, which is minus 2. Since 2 is not equal to minus 2, x is equal to 3 is eliminated. So C1 is 10 only. Let's continue with the second equation. Just like in the first equation, we're going to square both sides of the equation to have 2x squared minus 7 is equal to x plus 3 the whole square, which is equal to x squared plus 6x plus 9. Simplifying this equation, we have x squared minus 6x minus 16 is equal to 0. From here we have 8 times 2 and negative and positive. So x is equal to 8 or x is equal to minus 2. Let's check the solutions by substituting back into the original equation. When x is equal to 8, we have 8 squared, 64. 64 times 2 is 128, minus 7 is 121, square root of which is 11. And when x is equal to 8, we have 11 on the right hand side too. So the first one is okay. When x is equal to minus 2, we have 4 times 2 is 8. 8 minus 7 is 1, the square root of which is 1. On the right hand side of the equation, we have minus 2 plus 3, which is again 1. So this is also okay. So our solution set 2 is minus 2 and 8. And we're asked to find the union of the two solution sets. So C1 union C2 is minus 2, 8, and 10. And we're asked to find the elements of the union of the two sets. So the answer is 3. 29. The graph of the parabola is given in the figure. What is b times c? So we have the equation of the parabola and 2 points of the parabola are given. So 2 unknowns are there in the equation. We can find those 2 unknowns from the given points. When x is equal to minus 2, our y is 0. So 0 is equal to minus 4 minus 2b plus c. So this is our first equation. When x is equal to 6, our y again is 0. So minus 0 is equal to minus 36 plus 6b plus c. Let's multiply the first equation by 3. So we have, this is the first equation, multiplying this equation by 3. We have 0 is equal to minus 12 minus 6b plus 3c. Now let's sum them up. 6b and 6b cancel out each other. So we have 4c is equal to 48. From here c is 12. Let's substitute it back into the first equation to find b. So minus 4 minus 2b plus 12 is equal to 0. From here we have b is equal to 12 minus 4 is 8. 8 over 2 is 4. So b times c is 4 times 12. The answer is 48. In the figure, the graphs of the parabola and the line are given, and the shaded area is asked. To find the area, we need to know point H, the base of the triangle, and point A, the height of the triangle. Once we know the point A, we know both the base of the triangle and height of the triangle at the same time. So the key here is to find point A. How do we find point A? Since it is the intersection of parabola and the straight line, we can find the intersection once we know the equation of the straight line and the equation of the parabola. Let's first start with the equation of the parabola. To find the equation of the parabola, we need to know 3 points. Those points are given as minus 2, 3, and y minus 6. Let's write down the equation of the parabola. So let's say this is y1, this is y2. Okay, for parabola we have y, let's say just y is equal to x plus 2, x minus 3 times a. And we can also use this point. When x is equal to 0, y is minus 6. So when x is equal to 0, we have minus 6a is equal to minus 6. From here we have a is equal to 1. So the equation of the parabola is x plus 2 times x minus 3. How about the equation of the line? The equation of the line can be obtained by using this linear equation format. Y is equal to mx plus c. The slope of this line is rise over run. So this is 3, that is 3. So the slope is 1. Since it is going that direction, it's positive. So y is equal to x. How do we find the constant c? The constant c is 1, x is equal to 0, y is minus 3. So that's the constant. So we have this equation and that parabola equation. To find the intersection point, all we have to do is just equate these two y's. So x minus 3 is equal to x plus 2 times x minus 3. So this and that cancel out each other. We have x is equal to, this is 1, so it's minus 1. When x is minus 1, what is y? When x is minus 1, y is equal to minus 4. So this is the intersection point of the two graphs. So x is minus 1, y is minus 4. So this is minus 4, so that line is 4. So now we know the base and height of the triangle. The base is from 3 to minus 1. The distance is 4, and the height is 4. From here we have the area is equal to 8. So the answer is D. 31. Which of the following is the point of the parabola that is closest to the line? So we're given a parabola and a line. Let's draw a figure and try to understand the question first. So we have a parabola, y is equal to x squared plus 3. And we also have a line, y is equal to 2x. And we're asked to find the point on the parabola that is closest to this line. So how do we find that point? We can find that point this way. Let's draw a line parallel to y is equal to 2x. And when we move this line closer and closer to the parabola, at some point it's gonna touch the parabola. And that point is called the point of tangency. And we can find the closest distance between the line and the point on the parabola by drawing a perpendicular line. So this is the closest distance. And what is the coordinate of this point, or point of tangency? So to find this coordinate, let's write down the equation of this line first. Since these two lines are parallel, the slope of these two lines must be the same. So the slope over here is 2, so here it's going to be the same. And we don't know the constant of this equation. So let's say it's y is equal to 2x plus c, and the slope is 2 here. And from derivative, we can also find the slope of the parabola at that particular point, which is y prime. Y prime is equal to 2x. And the slope on that point is the same as 2, since it's on the same line. From here, we have x is equal to 1, and that is the coordinate of point of tangency. How do we find y coordinate again? All we have to do is just substitute x is equal to 1 into the equation of the parabola here. So we have y is equal to 1 squared plus 3, which is 4. So that's the answer to this question. So it's A. We can also solve this problem without using derivative, actually. At the point of tangency, both the linear line and the parabola share the same point. So we can write the equation together at that particular point. So x squared plus 3 is equal to 2x plus 3. From here, we can find x squared minus 2x plus 3 minus c is equal to 0. Since the parabola and the linear line are tangent to each other, the discriminant of the second order equation must be 0. B squared is this minus 2 the whole square, which is 4 minus 4 times a is 1, and c is 3 minus c. From here, we can find that 4 is equal to 4 times 3 minus c. C is equal to 2. Let's substitute this c value here. So we have y is equal to 2x plus 2, and these two y's are equal at the point of tangency. So let's write down this equation. X squared plus 3 is equal to 2x plus 2, and x squared minus 2x plus 1 is equal to 0. So x minus 1 the whole square is equal to 0. From here, we have x is equal to 1. So that's the x coordinate of the point of tangency. To find y, all we have to do is just substitute this value into any of these two equations. So let's substitute this x is equal to 1 into this equation. So 1 squared plus 3 is equal to 4. So we have the point of tangency, which is 1 and 4, as we have found before. 32. The bisector is given, and there is one right angle over here, and ED and BC are parallel. These two lines are parallel to each other. and we have AD is equal to DC. HP is also given. The area BDE is asked. Let's say this is A and that is B. From the bisector theorem, we know that A times B is equal to 6 times this side, which is 8. 6 times 8 is equal to AB. So the area of this triangle is half base and height. So the height of that triangle is over here. So area of ABC is equal to half base is A and height is B. Since AB is known, the area can be calculated as 24. So this area ABC is obtained, and these parallel sides are given. If these two have the same length, then AE and EB must be the same too. If the area AED is A, then the area DEB is also A because they have the same height and the same basis. So if this is A, that is also A. From the vertex B, when we look at this triangle, it's 2A. So we should also have this triangle as 2A because AD and DC are the same. So now we have the triangle ABC in terms of A. So A plus 2A is 4A, which is equal to 24. From here we have A is equal to 6. And what we have been looking for is the triangle EBD, which is A. So the answer is D, number 33. The right triangle is given, and the length of BE, CE, AC, and BD are given in the figure, and the area BDE is asked. So let's draw a parallel line from point E to the base DB of the triangle EDB. So we have this, and this is H. Now we have two similar triangles, the small triangles and the large triangle here. Let's take the similarity ratios. H over this side, 10 is equal to 3 over 15. 5 times 2, 5 times 3. From here we have H is equal to 2. So the area of triangle BDE is half the base is here, and the height is known as 2. So the answer is 8. 34. AB and AC are equal, it's given, and BC and CD are equal, it's also given. X and Y over here, and the summation of x plus y is given. The angle ABC is R. So let's start from this isosceles triangle. Since this one is y, this one should also be y. And the summation of the two interior angles is the same as the exterior angle. So this is 2y. And AB and AC are equal. So angle ABC is equal to angle ACB. So this is 2y. Now in the triangle ABC, the summation of all the interior angles is equal to 180 degrees. From here we have this equation, and another equation with x plus y is also given. So let's subtract these two equations to have 3y is equal to 60. From here we have y is equal to 20, and we're asked to find ABC, which is 2y. Since y is 20, 2y is 40, so the answer is D. The triangles in the figure are equilateral triangles. Let's just name them. This is x, this is x, this is x. Let's say this is y. All the sides are equal, and this is z, that is z. This one is also z. AB is equal to 18. So AB is the sum of x plus y plus z. Okay, what is the sum of the perimeters of the triangles above? So the sum of the perimeters can be written as 3 times x plus y plus z. Since x plus y plus z is known, the answer is 18 times 3, which is 54. So the answer is D. 36. DA is perpendicular to AC. It's given in the figure. 30 degrees also given. BE is equal to EC, and 4√3 is over here. And the angle AEB is twice BED. So if BED is theta, AEB is 2 theta. And we're asked to find BD. So this one is asked. Since this median is drawn from 90 degrees, we know that BE is equal to EC is equal to EA. And 30 plus theta is here. And this one is an isosceles triangle with these two sides equal. So we have this angle and that angle equal. 30 plus theta here. And the summation of all these three angles is equal to 180 degrees. 60 plus 2 theta plus 2 theta is equal to 180. And 4 theta is 120. From here we have theta is equal to 30 degrees. So if theta is 30, this angle is 60 and this is 90, so that one is 30. So we have a special triangle here with 30, 90, 60. The opposite side of 60 is 4 root 3. That means the opposite side of 90 is 8. So this one is 8. Since these two sides are equal, so each of them must be 4. Since these two sides are also equal, theta, we got theta 30 over here, so this is 30 and that is also 30. So these two sides are also equal. From here we have BD or X is equal to 4. So the answer is A. 37. CD and DA are perpendicular. It's given here 60 and 150 already in the figure. Root 3 and 5 also here. We're asked to find AB, this one. So let's extend this line all the way here. Let's connect these two. So if this is 150, this one is 30, this is 60, this one is 120, this is 120 and 30, which makes 150. So the last angle is 30. So we have 30, 30, 120. So these two are isosceles. So this one is 30 and this one is 90. This angle over here must be 60. So we have a special triangle here. The opposite side of 30 is 5. So the opposite side of 60 must be 5 root 3. And this one is 10. Since the whole thing is 5 root 3 and we already have 5 root 3 over here, so this part is 4 root 3 over here. So let's draw another line from B to the base of the triangle so that it is perpendicular. Since this is isosceles triangle, this line divides the base into two equal parts. So the entire length is 4 root 3, so this one is 2 root 3 over here. So this is 60 degrees and that is also 60. The properties of the isosceles triangle. So the opposite side of 60 is 2 root 3. That means the opposite side of 30 is 2 and the opposite side of 90 is 4. Since this side and that side are equal, this is also 4. And we're asked to find AB. Since the entire length is 10, AB is 10 minus 4, which is 6. So the answer is C. 38. The figure is a unit cube. So that's important. Unit cube means all the sides of the cube are equal and each side has 1 unit. And points E and F are the centers of AL and BK. Arc AL is here, arc KB is here. F is a center, E is a center. And we're asked to find the shaded area. So to make it easier to calculate, I'm going to straighten out this arc length. So we have a strip like this. So this is L and that is K, and this is A and B. So the length of the LK is 1 because it is given to be a unit cube over here. So what is this length KB? KB is the arc length over here. How do we find the arc length? This is 90 degrees. We know that S is the arc length over here is equal to theta R. R is the radius, theta is the angle at the center. So theta here is 90 degrees. In terms of the radian, we can write this as pi over 2, and the radius is either this one or that one. Since it is a unit cube, the radius is also 1. So we have S is equal to pi over 2. And this arc length is the same as KB over here. So this is S, which is pi over 2. So how do we find the area of this rectangular shape? It's just a multiplication of the width and the length. So pi over 2 times 1. So the answer is pi over 2. It's A. 39. Which of the following is the equation of the circle, that is the reflection on the circle with respect to the line y is equal to x? So we're given the equation of the first circle, and it's going to be reflected about this axis, and we'll have a second circle, and we're asked to find the equation of that circle. So let's draw a figure so we can see it clearly. So we have x-axis and y-axis, and the line y is equal to x. So what is the center position of this circle? So we know that the equation of circle is x minus x1 the whole square plus y minus y1 the whole square is equal to radius square. So the center position of the first circle is x1 and y1, and we have the first circle center as 0 and 2. So let's draw it on the figure. So it's 0 and 2, so it's over here. So that's our first center. And it's going to be reflected about y is equal to x-axis. That means our new center will be on the x-axis with the coordinate 2, 0. So we're asked to find the equation of that new circle. So x minus the new position of x is 2, the whole square plus y minus the new position of y, the whole square is equal to radius square. Since the radius doesn't change by reflecting the center from y-axis to x-axis, it is the same as before, which is 5. So our answer is x minus 2 the whole square plus y square is equal to 5, which is A. 40. M is the center, and point A and B are given. A is 2, B is 6, and everything else is as given in the figure. We're asked to find the radius of the circle. So that is the radius. And let's also draw a line from M to the chord AB perpendicularly. From the circle theorem, we know that these two lines, let's say this is point C, BC and CA are equal. So the distance between B and A is 6 minus 2, which is 4. Since CB and CA are equal, so the distance should be 2 over here, 2 down there. So OC is 2 plus 2, which is 4. It's the same as MT. MT is the radius of the circle, so our answer is B. This is the end of the math part of the exam. I hope you get something out of it. See you in the next one.